Hi, everybody. What I'm going to do today is I'm going to show you all basically that inequalities are very similar to equations. The difference is the number of solutions that we get, which a lot of times is there are an infinite number of solutions, different than the all solutions that we get from some equations where they're identities. This is a different situation where you can have an infinite number of solutions. This particular case actually has a limited number of solutions, and they are all whole number solutions. So we're going to look at the situation. I'm going to write the equation, solve the equation, and then rewrite it as an inequality. So we're going to start with an equation. Mr. J and Rick plan to go bowling at the Orleans, and games are half price and only cost $1 each. Shoe rental costs $1.50. If they can spend at most $20, how many games can they play? So a lot of people are going to interpret this to mean that they want to spend the $20. And if they solve it and they end up with a number that's bigger than, say, 4 or 5, and they get a decimal, then pretty much they realize that they can play 4 games if it's 4 point something. And they're going to have some change coming back. But the true interpretation of this is as an inequality, which is true of almost everything in life. For this example, though, what I'd like you to do is try to set it up yourself. Literally, pause the video and try to set it up as best you can. There is what we call a initial cost, and that is the cost of the shoe rental. And then there is the cost that per game. Now, the problem is that there's 2 of us. So that means that we have to double both of these. There's going to be 2 shoe rentals, assuming you don't have bowling shoes, and there's going to be 2 games for each person each time they play. So we're going to set this up like as follows. We're going to say the $3 is the cost for renting the 2 pairs of shoes for myself and Rick. Then we are going to spend $2 for every game we play because we're both going to play the game. And we want to spend at most $20. Now, what we've done in the past is we would just simply write equals 20. And this is the way we would solve it. And we would solve this equation. To solve this equation, we subtract 3 from both sides. And we get $2 for each set of games, actually, is 17. And then we're going to divide by 2. And G is equal to 8.5. Well, we're not going to play 8.5 games. We're literally going to play 8 games. And we're going to get some change back. Hopefully, all of this is clear. Now, the difference is when you do an inequality, it looks very similar. It's going to be 3 plus 2G. And this is the amount of money that we spend based on the number of games we play. And we want it to be less than or equal to $20. And now we can solve this inequality by subtracting 3 from both sides, which is still acceptable. We solve inequalities similar to the way we solve equations. And then we divide by 2. And this is a different situation. Now, if I'm truly asking what is the most number of games they can play, the answer would be 8 games, either way. 8 is the largest number of games that is less than or equal to 8.5. But the thing about this particular problem is that this inequality says that it could be less than or equal to 8 games. So they could play 0 games, of course, and pay for the shoes and, I don't know, wear the shoes around. They could play 1 game each, or 2, or 3, or 4, or 5, or 6, or 7, or 8. All of these solutions make this true. Now, we can't really talk about negative games, but we can talk about the number of games they could play, and this is the solution set. So I'm going to go on to the next one. I don't know why I'm getting such a fade out. I think it's because of the sun, maybe. Wow, that's really ugly. Oh well, I'm gonna look funky. All right, so we're gonna go to the next example. And this one, I didn't move it out of the way, darn it. Very irritating. Come on, there we go. This one out of the way as well. Okay, there we go. I may redo this one. I can't believe this looks so bad. All right, what we're gonna do is we're gonna see if we can set this up. Now I'm gonna follow the 5 problem solving steps. And the first step, I should have said that this is a rectangular garden in the directions. So this is a rectangular garden. And it says the length needs to be 3 feet less than double the width. This is a very important idea. You need to write the equation that goes with that. And there is an equation, not an inequality. Let me move this out of the way a little bit here. Let's move this down a bit so that I can deal with this problem here. Okay. Our first step in my 5 problem solving steps is to draw a diagram. And I'm just going to draw a rectangle. This is supposed to be a rectangle. Now I could use the drawing tool and make it nice, but it's good enough. The length needs to be 3 feet less than double the width. This is the length, L. Needs to be, or is, or will be equals 3 feet less than double the width. Well, the double the width is 2W. We know that. The less than is the problem child. This means reverse subtraction, and it's very important that you get the reverse subtraction in there. That means that we have to turn this around. So we get 2W minus 3. Now, I'm going to label my diagram. Length is 2W minus 3. The width is just W. And it says we have 100 feet of fencing. Well, we have to recognize that we're talking about a total amount of fence, and it goes around the garden. Well, this is called the perimeter. And so the formula we want, by the way, I have a labeled diagram here. The formula I want is I want the perimeter to be equal to 100 because they said they want me to maximize the area. That means I want to use the whole 100 feet of fencing. So I'm almost done. I have a diagram, I have it labeled, and if you remember, hopefully you remember the next step, it's the formula. And the formula for the perimeter of a rectangle is perimeter equals 2 lengths plus 2 widths. And now we're just going to substitute. Inside parentheses is usually best. But I'm going to go ahead and substitute for the perimeter. And instead of L, I'm going to put 2W minus 3. Don't forget the 2W right here is still there. Now, my next step is to simplify. There's nothing to do inside this parenthesis, so that it's gone. I can distribute the 2 to both parts and add the 2W. I'm going to do it in 2 steps, but normally you could probably do this in your head, but I'm going to distribute the 2 to both parts. That gives me 4W minus 6 plus 2W. Now be careful. This 2W and this 4W are on the same side, so you have to add them together. That is 6W minus 6 is equal to 100. Now at this point, we have a 2-step equation that we need to solve, and we can find the width. In order to find the width, we're going to add 6 to both sides and divide by 6. And what we're going to get is an improper fraction, possibly a mixed number if you like, and it's not going to be a really nice answer, but that's okay. There's not a problem with that. Now, I'm going to add 6 to both sides. And I'm going to get 6W is equal to 106. And we're going to divide by 6 on both sides. Now I can reduce this a little bit. And W is equal to 6 goes into 106. So let's do the division just real quick. 6 goes into 10 one time, and we have 46 left. 6 goes into 46 7 times, and we have 4 left. This is not 0.4. This is 4/6 or 2/3. So the width is 17 2/3 feet. Now, a lot of people are going to say, well, I'm done. I've found the width. Well, yes, you've done part of the problem. The next part of the problem is to find the length, because in order to find the area, we would have to know the length. And the length is equal to 2w minus 3. And I'm going to substitute my w into this equation so that I can find my length. Well, what is the width? 17 2/3 feet. A lot of people are going to want to change this to an improper fraction and then multiply by 2 and then subtract the 3. For me personally, I'm just going to do the following. It's a little different way to do this. I'm going to multiply it by 2, which gives me 34 4/3. I know it's 35 1/3, but I'm going to subtract 3 and I'm going to get 31 4/3. And then that gives you 32 1/3. So either way, hopefully you can see how this works. If you wanted to, you could have taken the 34 times 3, added it to the 4, subtracted the 3, and done the division, which is a real pain. You could grab a calculator. The problem is that the 17 2/3 is 17.66666666 repeating. So no matter how you do this, hopefully this makes sense to you. This was my answer, but keep in mind that that improper fraction is wrong. You should actually add the 1 extra to the 31 to make it 32 1/3 feet. Sorry, it's a little ugly there, but there's my length. So I now have a length and a width. And in order to find the area, I have a formula, length times width. And I'm just going to go ahead and put the length, 32 1/3, and the width, 17 2/3. And I can get the answer by multiplying those two together, and I will have it in square feet, and that will be the maximum square feet possible. Now, a lot of people would just assume that they're supposed to just round it off to the smaller one, and they're going to have a little bit of fencing left over at the end. If you wanted to ask for a whole number, then you would not round it up. You would literally round this down to 17 so that you would be able to get the correct length. Anyway, hopefully that's clear, and I don't want to spend much more time on this, so good luck. I'm going to put in the description of this one, I'm going to include 2 more examples. So bye-bye.